So 2018 FRQ question number 1. So if you look over this question, you're going to see it's really similar to the 2019 number 1. And in fact, if you go back through the years, you're going to find they always have a question like this. It's normally number 1. So in a normal year, we would say, that's a pretty good indicator that they're going to have a question like this. And usually pretty early in the set. Of course, this year all bets are off. However, they really like these questions, and I would be surprised if there wasn't something in this format there. So, all right, what have we got? They give us some kind of a rate. It's the rate of people per second entering an escalator, entering the line for the escalator. And so, hopefully you've had some time to read over that. We've got some background information here. And then the question part A, how many people enter the line for the escalator during the time interval 0 to 300? So they also, they always start with something a little bit easier, right? So this is just ask how many people enter the line. So it doesn't matter about the people who are already in line. All they're asking us to do is to do an integral of this rate over the time period 0 to 300. They don't even ask us for interpretation or units or anything. All we have to do is, for 2018, let's get this centered here, 2018 number 1, part A. All we have to do is the integral from 0 to 300. Oops, that's not 300. 300 of r of t dt. That's all we have to do. Now, in terms of calculator technique, because these are calculator active, we see that there's going to be a lot of questions about this function. Therefore, it's a good idea to put that function into your y equals. I've already put it in. I mean, it's kind of interesting to think about this function, about how as t approaches 300, what's happening to this term over here is that 300 over 300 is 0. So as the t gets closer to 300, we have, it starts out as 1 to the 7th power and then drops down to 0 to the 7th power over this time interval. And since it's 7th power, that means if you just look at this factor right here, it's going to stay really solidly flat at 1 and then rapidly drop off as we get to 300. So that's what this factor does, is it drops the people off very rapidly as we approach time equals 300. But then this function, this factor, is increasing as a cubic throughout the whole interval. But then this 7th power is going to sort of overwhelm that and cause the, so we expect that this, graph is, you could think about it as going to look something like that. You don't have to think about any of that, though. You could graph it if you want. I'm not even going to bother. I'm just thinking about how, they didn't write these things totally randomly. They wrote them with some purpose in mind. And it's, now that since we're not under a time constraint right now, it's worthwhile thinking about those things. And then when you're doing the test and you are under time constraint, you sort of have the idea of how they think about things, which is a good thing to have. Anyway, so I'm basically just stalling because this is going to take 2 seconds to do. Once we know that we have to do this integral, all we have to do is go to get an integral and go math 9 for an integral. We have to do 0 to 300. And since we've put our function in y1, we can just go vars y vars enter y1 and then do dx enter, and everybody should be able to get this point that it's 270. So it equals 270 and we're done. See, now we go on to part B.